Science, Chapter 18, Thermal and Light Energy. Thermal and Light Energy. Chapter 18, Vocabulary, Thermal Energy, Heat, Conduction, Convection, Radiation, Insulator, Conductor, Refraction, Reflection. How is thermal energy transferred? Thermal energy is the total kinetic and potential energy of the particles in a substance. Heat is thermal energy that moves from one substance to another. Heat can move by conduction, convection, and radiation. Thermal energy. When you look at the molten glass, it is easy to see that its particles are moving. The molten glass flows, but a solid object, such as a glass pitcher, seems to be perfectly still. Are you surprised to find out that it's not? All matter is made of particles that are always moving. The particles have kinetic energy, or energy due to motion. The particles in a substance always pull on each other. This means the particles have potential energy, or energy due to position. Particles in a gas can move freely. They do not pull strongly on each other. Particles in a liquid can only flow around each other. They pull more strongly on each other than gas particles do. The particles in a solid pull strongly on each other. They vibrate, but they cannot move from their fixed position. The total kinetic and potential energy of the particles in a substance is thermal energy. The amount of thermal energy depends on the amount of the substance. If you have a cup of water and you pour half of it out, the part that is left has half the number of particles. It therefore has half the thermal energy that the full cup of water had. Thermal energy determines how warm a substance feels. A warm cup of water has more thermal energy than a cool cup of water. The warm and cool water have about the same number of particles, but the particles in the warm water are moving faster. They have more kinetic energy. Therefore, they have more thermal energy and feel warmer. Heat. You've probably measured your kinetic energy many times, but you may not have known it. Temperature is a measure of the average kinetic energy of an object's particles. When you take your temperature with a thermometer, your body heat increases the kinetic energy of particles of a liquid in the thermometer. The thermometer then shows the average kinetic energy of particles in your body. Temperature is not the same as thermal energy. Temperature depends only on the average kinetic energy. Thermal energy is the sum of kinetic and potential energy. Unlike thermal energy, temperature does not depend on the amount of a substance. If you split an object in half, each part has half as many particles, but the temperature does not change. The average kinetic energy is the same. Thermal energy that can move from one substance to another is called heat. Heat always moves from a warmer substance to a cooler one. An increase in temperature means that heat moves into a substance. When heat moves into a substance, the average kinetic energy of the particle rises. The extra kinetic energy increases the particle's vibrations. Particles vibrate faster when a substance is heated. The movement of heat from one substance to another can occur between objects that touch and objects that don't touch. The three types of heat transfers are conduction, convection, and radiation. Conduction. Heat transfer between two objects that touch is called conduction. Think about what happens if you place ice cubes in a glass of warm lemonade. Do the ice cubes cool the lemonade, or does the lemonade warm the ice cubes? The temperature of the ice cubes is lower than the temperature of the lemonade. The particles that make up the lemonade are vibrating faster than the particles of the ice. When the ice touches the lemonade, the particles in the lemonade bump against the ice particles. This causes the ice particles to move faster and faster. Heat flows from the warmer lemonade to the cooler ice. The lemonade particles slow down. Conduction of heat has warmed the ice and cooled the lemonade. When heat moves by conduction, the particles in the substance do not change their location. Energy is passed from particle to particle as the particles vibrate and bump against other particles. The movement of energy may occur between a warmer substance and a cooler one. It may also occur between the warm part of an object and a cooler part of the same object. Convection. A hang glider soars through the air, swooping up and circling again and again. The wings of the glider provide balance. But how is the glider able to move upward? Hang gliders depend on the movement of thermal energy in the air. Heat moves from the warm ground to the air just above it by conduction. As with solids, the kinetic and potential energy of particles in a fluid, a liquid, or gas increases if the fluid touches a warmer object. Energy from the warmer object moves into the fluid. As the fluid becomes warmer, its particles move faster. The density of a fluid decreases as the fast-moving particles spread apart. A fluid with a higher density sinks below a fluid with a lower density. This causes the lower density fluid to rise. When this happens, the rising fluid carries thermal energy along with it. Convection is the transfer of thermal energy by the movement of the particles of a liquid or gas. This movement results in a stream of fluid called convection current. Hang gliders can fly great distances as they are continually pushed upward by convection currents along the way. Convection currents in the air cause wind to form. As warm air rises, cooler air rushes in to fill its place near the ground. The rising warm air becomes cooler and begins to fall. The cooler air near the ground becomes warmer and begins to rise. A pot of boiling water is another example of convection. If you place a pot of water on a stove, the temperature of the pot rises by conduction. Heat moves from the stove to the pot. The pot then warms the water that touches it by conduction as heat moves from the pot to the water. The warm water is less dense than the cooler water above it. The cool water then sinks, causing the warm water to rise. The rising and falling of warmer and cooler water increases the temperature of the entire pot of water. Radiation. For the chameleon, a good way to spend a sunny afternoon is sitting on a rock. Like all reptiles, chameleons warm their bodies with energy from the sun. This energy must travel from the sun to Earth through space that has almost no matter. Radiation is the transfer of thermal energy as waves. It can involve energy transfer through matter or across empty space. When solar radiation reaches Earth's atmosphere, some of the energy is reflected back toward space. The rest of the radiation reaches Earth. Like the atmosphere, Earth's surface reflects some radiation and absorbs the rest. The absorbed radiation heats Earth's surface, which releases some of this heat back into the atmosphere. There, gases such as carbon dioxide and water vapor absorb the energy and become warmer. These gases surround Earth and act like a blanket to hold heat. This process by which the atmosphere holds heat is called the greenhouse effect. The greenhouse effect is a natural process. Without it, Earth would be a cold, lifeless planet. But some scientists are concerned that the increase in some atmospheric gases, such as carbon dioxide, will cause the atmosphere to become too warm. Increased temperature can have a harmful effect on Earth's ecosystem. Insulation. Brr, it's a cold winter day and you're getting ready for school. You put on a thick coat, scarf, and gloves to keep warm. Winter clothes keep you warm because they insulate you against the cold. An insulator is a material that does not easily transfer heat. Other materials, such as metals, are conductors. They transfer heat easily. What causes a material to be either an insulator or a conductor? Recall what happens when heat moves from a warmer object to a cooler one. Particles in the warmer object move faster. If the warmer object touches the cooler object, particles in the warmer object bump against particles in the cooler object. Particles in the cooler object then move faster and faster. Their kinetic energy rises. The temperature of the cooler object rises by conduction. Some materials are good conductors because their atoms can easily vibrate to transfer heat. Metals, such as copper and silver, are good conductors because of the movement of electrons. Some electrons are not tightly held to the atoms of the metals. These electrons can move easily. They carry energy from place to place. You may have realized that metals are good conductors when you've stirred hot soup with a spoon. After a short while, you can feel the heat in the spoon. Liquids and gases are usually better insulators than solids because their particles are farther apart. Empty space is also a good insulator. Heat cannot move through empty space by conduction or convection. Using insulators. Understanding insulators is important in choosing clothes for cold weather. Layers of materials will keep you warmest. They contain pockets of air. Because air is a good insulator, heat cannot easily escape from your body. Insulating materials are also important in home building. If you've ever seen a house being built, you may have seen thick layers of insulating material placed in the walls and attic. Air pockets within the layers slow the movement of heat out of a home on cold days. They also slow the movement of heat into a home on hot summer days. Some houses have windows with double layers of glass. The pockets of air between the layers is insulation against the movement of heat through the window. Insulation is one way that animals protect themselves from the cold in winter. Some animals have thick layers of insulating fat. Animals may also have fur or hair that traps heat close to their bodies. Lesson checkpoint. 1. How does a liquid thermometer show that you have a fever? That can be found back on page 504. Liquid thermometers measure temperature change when increased kinetic energy causes a liquid to expand. Digital thermometers measure temperature change when increased kinetic energy causes a metal to expand. Number 2, why are you warmer if you wear layers of clothing on a cold day? I want you to think about insulators. If it's cold outside and the air is really cold, what's stopping the cold air from touching your body? It would be those thick layers of clothing, right? So why are you warmer? The clothes are helping to insulate you. Compare and contrast. Explain how conduction, convection, and radiation are alike and how they are different. I want you to do that on your own. Lesson 2. How do waves carry energy? Waves such as sound and light carry energy. When light strikes matter, it may be absorbed, transmitted, or reflected. Light may change direction when it moves from one material to another. Types of waves. Have you ever dropped a rock into a pool of water? Waves spread out in all directions from the point where the rock enters the water. The rock causes molecules in the water to move back and forth as a vibration. A wave carries energy away from a vibration. The illustrations below show the two main types of waves. Notice their differences. When waves move through matter, the matter does not move along with the wave. When transverse waves move through matter, they cause the matter to move in a direction different than the waves move. If the wave is moving to the right, molecules in the matter move up and down. If a compressional wave is moving through matter, the matter moves back and forth in the same direction as the wave. The particles in the matter move forward and then backward over and over again. An important type of compressional wave is sound. As with all waves, sounds are caused by vibrations. Think about what happens if you strike your pencil against a desk. The force of your pencil causes molecules in the desk and air next to it to vibrate. These vibrations cause nearby air particles to vibrate, and they cause other molecules to vibrate. The vibrations move outward through the air in all directions. You hear sound when the vibration reaches your ear. You can also hear the pencil striking the desk if you place your ear against the desk. Sound waves can travel through matter, but they cannot travel through empty space. Electromagnetic spectrum. You just read about sound waves that travel through matter. Like sound, light travels as a wave. But unlike sound, light can travel through empty space. Light travels as transverse waves. Visible light is only one of the many kinds of waves that travel to Earth from the sun. If you arranged all kinds of waves from the shortest wavelength to the longest wavelength, you would get a pattern similar to the one shown in the diagram above. The pattern is called the electromagnetic spectrum. Notice that the wavelength becomes longer as you move from left to right across the spectrum. But the frequency becomes shorter. Like all waves, those of the electromagnetic spectrum carry energy. Waves with a shorter wavelength have more energy than those with a longer wavelength. Absorption of light. Shine a light on a piece of glass, and most of the light travels through it. Shine the same light on a piece of metal, and no light goes through it. Light can behave in different ways when it strikes matter. Some light may be absorbed or taken in by the matter. When light enters a material, some of the light energy is changed into heat energy. You may have noticed this on a warm summer day. Dark-colored materials absorb more sunlight than light-colored materials. Wearing a black shirt, for example, makes you warmer than wearing a white shirt. Light may also pass through a material without being absorbed. The amount of light that passes through a material depends on the type of material. Almost all light passes through transparent materials. such as clear glass and water. Translucent materials only allow some of the light that strike them to pass through. Wax paper is a translucent material. Opaque materials don't allow any light that strikes them to pass through. Wood, rocks, and metals are examples of opaque materials, which means you cannot see through them. All electromagnetic waves travel through the empty space at the speed of light, 300,000 kilometers per second. Light travels through matter at speeds less than this, but light doesn't pass through all materials at the same speed. The particles that make up matter cause light to slow down. The speed that light passes through a material depends on the type of material. Unlike sound waves, light usually travels slowest through solids because they have the highest density. Light travels faster through liquids and even faster through gases. Refraction and reflection. Light changes speed when it moves from one material to another. If a beam of light strikes the border of two materials at an angle, the change in the speed of the light changes its direction. Refraction is the change in direction of light when it moves from one material to another. You can see refraction by placing a spoon in a glass of water and looking at it from the side. The spoon seems to be bent. This happens because the light changes direction when it moves from the water to the air. Light that hasn't absorbed and doesn't pass through a material is reflected. Reflection is the bouncing of light rays off the surface of a material. If the surface is smooth, you may be able to see your reflection in the material. When light strikes a mirror, for example, the light reflects back so that you can see yourself. Think about places where you can see your reflection. Why can't you see your reflection when you look at a wall or a book? These surfaces may seem smooth. Using a magnifying glass, however, you can see many bumps and holes. Light that strikes these surfaces bounces off in many directions. A surface must be smooth enough for light to bounce back to your eyes in order for you to see a clear reflection. Lesson checkpoint. Why can't sound travel through empty space? You're going to need to go back to types of waves to be able to answer that. Number 2, why will you likely be cooler if you wear a light-colored shirt instead of a dark-colored shirt on a warm day? That has to do with absorption of light, so you'll want to go to that section. And number 3, compare and contrast. Write a paragraph explaining why light and radio waves are alike and ways they are different. And then you have, this page is just extra, and then chapter 18, review and test prep. This is your review assignment number 1 through 20.